Homework sheet 3 video, As You Live and Breathe. How exciting is this? So, starting off pretty straightforward, sine, cos, and tan functions. Just finding our exact values. So this one, we can always add or subtract. In this case, because it's a tan pi, we'll add or subtract 2 pi. Because 13 pi over 2, it's kind of gone around the circle a bunch of times. But by doing that, we can just rewrite it as tan of pi on 2. Which of course is undefined, being at the top of our unit circle, we would not have a tan value. Again, 5 pi on 3 is the same as cos pi on 3, just in quadrant 4. Still positive though, so it just ends up positive a half. And tan 5 pi on 4, that is quadrant 3, tan still positive there, and that just equals 1. Pretty straightforward, those ones. All right, question 2. The first one's pretty straightforward. Basically, when we're doing these pi on 2 plus x or 3 pi on 2 minus alpha in these cases, you're looking at whether sine or cos is positive in that quadrant. So pi on 2 plus x would be in quadrant 2. And if you go around your unit circle, sine is positive in that quadrant. Therefore, we just do positive whatever our cos value is, because that's what we're converting between. So you'll always be given a cos value there. This one's a little trickier. So cos 3 pi on 2 minus alpha is in quadrant 3. Cos is negative in quadrant 3. Therefore, we do negative 0.7, which is what our sine value was. They're a bit weird. Just practice those a little bit, though. Get to know them. This next one's a goodie. You can use the sine squared plus cos squared equals 1 identity, but sometimes drawing a little triangle is the best way to go. So if we are doing our cos alpha, so I've marked my alpha location there, and I'm going to mark out my adjacent value being 5 and my hypotenuse as 13. I'm just getting all that information from up here. We've now got our triangle. Of course, we can use Pythagoras to find out what b equals, our 12, and then we can really just read from the triangle what our exact values will be. So tan of alpha is opposite over adjacent, so that's going to be 12 over 5. And sine alpha is going to be opposite over hypotenuse, so 12 over 13. But little trick to the question, we are talking about quadrant 4, where sine is negative, so our sine value must be negative for that one. Little trick there. That's a nice, easy way to find those. We're not trying to find out what alpha actually is, just what tan alpha and sine alpha are. Question 4. I've just factorized out our half from the sine function, so x minus pi on 2 became half bracket x minus pi. Didn't really need to do it, but let's have a look at it anyway. Amplitude, of course, is always the number in front of the sine value, how far up and down we're going. The range is our number out the front, plus and minus our amplitude. So minus 5 is negative 3, and 2 plus 5 is 7. And the period is 2 pi divided by n, in this case half, giving us 4 pi. Question 5, we could use our CAS for this one, which does help us a fair bit. So you can see I've got my 2 general solutions. Key feature, we must write our KES. If this was an exam question, we must write K is an element of Z, saying it's all the different integers. It did actually want us to find values between 0 and pi. So if I sub 0 and 1 in for my K values, I get my exact values of pi on 2 and pi on 3. Just be careful to not go outside your domain. So that's where I eliminated negative pi on 2 and 4 pi on 3. Lots of marks on that page. Question 6. I'm not going to go through question 7 with the full working. You can have a look at those solutions. We'll talk about that in a second. So we're looking at sine of 2x on 3 equals square root of 2 over 2. Our base angle, so when sine equals the square root of 2 over 2, is pi on 4, and it's positive in quadrant 1 and 2. Our period is 2 pi divided by 2 over 3, which gives us 3 pi. So our exact values are going to be pi on 4, and in quadrant 2, that's going to be pi minus pi on 4, which is 3 pi on 4. And working that out, it's going to become 3 pi on 8 and 9 pi on 8. Yep, happy with all that. We're then getting our general solution, so I've then added my period times k, period being 3 pi. but I've written it all as one fraction, just makes it a bit easier to work with. Then when I sub k in as 0 or 1 or -1, I get my exact values of -15 pi on 8, 3 pi on 8, and 9 pi on 8. There's much more detailed videos on Maths Factory if you want to check those out if you're not sure about that question. Question 7, find the sum of the solutions of all this stuff. You can see my first step was to do the square root of both sides, giving us plus or minus the square root of 3 over 2. That plus minus is really important because it means that we're effectively working with cos in all quadrants. Our base angle is pi on 6, but then we need to do 2x equals pi on 6, 5 pi on 6, 7 pi on 6, and 11 pi on 6. I've then divided everything by 2 and added the period times k, and it's giving us all those different solutions. And as another trick, it's asking for the sum of the solutions. So I've added all those solutions together. Little trick for that is pi on 12 plus 23 pi on 12 becomes 24 pi on 12. 5 pi on 12 plus 19 pi on 12 is 24 pi on 12, which is another 2 pi. So it's kind of like 2 pi plus 2 pi plus 2 pi plus 2 pi. Was that enough? 8 pi. You get it. If I had a nickel for every time that someone asked about that question, I'd have 5 nickels. So I don't know how much a nickel's worth though. Question 8. First step on this one is to, what have I just done there? To divide both sides by cos of 4x, which effectively cancels it on this side, or becomes 1. And I've also divided both sides by the square root of 3. The hint that we're going to divide by cos and not sine is we know that sine divided by cos is tan. So now we've got to tan 4x equals 1 on root 3, or root 3 on 3. We're just working with the period of pi, so just in quadrant 1 where tan is positive. So 4x equals pi on 6, being the base angle there. And then we just do our general solution through with our period of pi on 4, giving our general solution here to then work out our exact values of pi on 24, 7 pi on 24, 13 pi on 24, and 19 pi on 24. You can see those. I don't know why I'm reading them. I've done question II with a bit of working if you wanted to check out the work solution, or you can just bang it in your CAS with the domain. So you can't quite see the domain, it's just cutting it off there on the CAS just down here. But really, really important thing to type that in because we get those exact values. Why would you do all that work when you can just punch it in your CAS if it's a CAS question? So get smart with it. Well done. Lunchtime awaits. I'm off. Enjoy your weekend or whenever you're watching this.